Hello everyone, today we're solving problem 2874, maximum value of another triplet 2. So in the first version of this problem we had different constraints. Num's length was up to 100 and now it's up to 10 to the 5th. So we won't be able to solve this one with a triple for loop. We need to find a solution that runs in of n ideally. Let's suppose we have this array and we are iterating from index 1 to index n minus 1, and we are using our j pointer. J is the middle value of each triplet. Okay, so at each step we are trying to find the maximum triplet value that we can get, which includes our j middle value. So in this first case our triplet should include 6. In order to do this, we need to find the maximum value to the left of j and the maximum value to the right of j. So let's say we know we can get in O of 1 time the value to the left of j. In this case it's 12. And let's say we can get the maximum value to the right of j, which is 7. Okay, so now we know for a fact that the maximum triplet that we can get, which includes our value at index j, is 12 minus 6 times 7. Okay, this 42 is the maximum value that we can get for this triplet, which includes our index j. And similarly, we want to do the same with each index. For example, let's say we're here. We get the maximum value to the left, which is 12, minus 1 times 7. And this is the solution for this problem. So how can we get the maximum value to the left and the maximum value to the right for each index? Well, we can use a prefix maximum array and a suffix maximum array. So the prefix maximum array, in case you know, will include all maximums from 0 to each index. So for example, we start here. First value will be 12, second will be 12 because 12 is greater than 6, third one is 12 also, 12 and 12. So this is our prefix maximum array. And now we also need a suffix maximum array, and we will iterate this from bottom to top. So at each step we want to get the maximum value until that index from bottom to top. So here is 7, that's our starting value. Then we have another 7 because 7 is greater than 2. Then 7 because 7 is greater than 6, and the first value is 12 because 12 is greater than 7, which was our previous maximum. So now we can iterate over each index, okay, from 1 to n minus 1 and implement our formula. So let's say we're here at index 1 and our value is 6. Okay, this is the value at nums 1, and the prefix value at j minus 1 is 12. Okay, this is the maximum value that we have seen until this index 1. So 12 minus 6 times the value of our suffix maximum array to the right of the current index, which is 7. So we are at index 1 and we are taking the left value of our prefix maximum array and the right value of our suffix maximum array, we are doing our formula, which is over here, and we are getting the maximum result at each step, and then we only need to return the maximum value over all the triplets. And that's it. Let's go over the result just to make sure it works. Let's say we are here at index 2 and we want to get the prefix maximum value to the left, which is 12, minus our current nums value 1 times the suffix maximum value to the right, which is 7, and this is the result. So now let's go with the code and hopefully this will all make sense. Okay, so first we'll say n is equal to length of nums, and we want to create our prefix maximum array and our suffix maximum array. So prefix max equals 0 times n, and suffix max equals 0 times n. Now we will set the first value for our prefix to num0 and the last value for our suffix to the last value at nums. So prefix max 0 equals num0 and suffix max minus 1 equals nums and minus 1. Now we want to iterate over our nums and fill our prefix max. So for I in range in prefix max of I equals to the maximum among prefix max of I minus 1 and nums of I. And similarly we want to do the same with our suffix max. So for I in range and minus 2 minus 1 because this is a reverse loop. Okay, suffix max of I equals the maximum among nums I suffix max I plus 1. Okay, so now we need to iterate over our original array from 1 to n minus 1 and get the maximum value. So we will store this maximum value here at our result variable, at our result, and for j in range 1 to n minus 1, our result is equal to the maximum among prefix max I minus 1, so the value at the previous index in our prefix max minus our current value times the value at the next index at our suffix max array. So suffix max of I plus 1. Here I'm missing the result, and here a parenthesis. Finally we return the result. So return, if I'm not wrong, this is the final answer. This should work, so let's see what happens. Okay, I got an error. So this is a J, and I wrote an I here, so this is J, this also is J, and this is J also. So now this should work. And it does, and the time complexity, as we said before, is often, and the space complexity is also often. So if you found this useful, please drop a like, subscribe, and see you next time. Bye bye.